In this lab, management wants us to upgrade the Internetwork Operating System, or iOS, of a Cisco switch. Specifically, management wants us to use the Trivial File Transfer Protocol, or TFTP, server to send a new iOS upgrade to the switch. An iOS image file is a file that contains a complete copy of the operating system environment and software, almost like a photograph taken in a point of time, hence why it's called an iOS image. This iOS image must be placed in a device's flash memory, so we can boot up the network device with the new image. Continuing with the image analogy, a network device's memory is called flash memory because of how fast the memory can be rewritten, like the speed of a camera flash. There are two ways of sending the iOS image to a network device's flash memory. You can use a USB stick where you copy the new iOS image file to the USB. Then you insert the USB drive into the network device's USB port. And then copy the iOS image file to the internal device's flash memory, where you can then use it to boot up the device with the new image. The second way is through a TFTP server. TFTP servers don't have to be an actual server, it can be an application on your laptop. For example, SolarWinds TFTP server is a free TFTP server you can download to your laptop to send an iOS image to a network device. Your laptop would need to be able to reach the network device, whether it be a router or a switch, over the network in order to send it the iOS image. Something to keep in mind is that you can't send the iOS image through a console cable connection, as console cables use a serial connection that only works at the physical layer of the OSI model, meaning no IP packets can be sent. So, in this case, we have a TFTP server connected to the switch so we can send over the iOS image. So let's first console into switch S1. Let's see what software version our switch is running with the iOS image it currently has with the show version command. The C2960 means this software is specifically geared towards 2960 switches. The Cisco LAN-based -M is the feature set for this software build. The version number 12 is the major version number release meant to track major updates and new features. The .2 is the minor version number release, which is meant to track minor updates and bug fixes. The 25 in parentheses is the maintenance release number, which is meant to track periodic bug fixes and stability improvements to the software. And the SEE1 means Service Exchange Edition Release 1. Now that we've seen the current version, let's view the contents of our switch's flash memory with the show flash command. Notice we have the iOS image that the switch is currently using. We can tell because the file ends in .bin, which stands for binary, as the file contains the binary machine code for the processing unit of the switch. Binary machine code uses ones and zeros and is able to be executed by the CPU or computer processing unit without an interpreter. If we do a show boot command, we can see that the switch boots up with the iOS image from our flash memory. So what we want to do now is copy the iOS image from the TFTP server by using the command copy tftp flash. The switch will then ask what the IP address of the device running TFTP is. In this case, it's our TFTP server's IP address. Then it's going to ask for the file name of the new iOS image we're trying to grab from the TFTP server. Management told us the new upgraded iOS image is 2960-LANbase K9-MZ.150-2.se4.bin, which we can see here in the TFTP server. So let's type that into the command. It'll then ask if we want to change the name of the file when it lands in the destination here in the flash memory. Since we don't want to, let's just press enter. Once you do that, it'll connect to the TFTP server and download the iOS image to the switch. Now, if you do a show flash command, you'll see both the new iOS image and the one this switch is currently using. But if you do a show boot, you can see it still wants to boot from the old image. So we'll have to jump into global configuration mode with config T, and then use the command boot system, and then copy and paste the file name of the new iOS image. Now if we do a show boot, we can see that it will boot into the new iOS image we asked it to. In order to reboot the switch, we'll have to do a reload command from privileged access mode. But before you hit reload, make sure it's after work hours or while everyone is at lunch, because everyone connected to the switch will lose connectivity as the switch reloads. Once you hit enter, it'll ask if you want to save. If you hit enter without typing Y for yes or N for no, it'll ask you to please answer the question. Once you type in Y for yes, it'll save the configuration and ask you again if it should proceed with the reload. Since management has given you the go-ahead, press enter and watch as it loads up the new iOS image. You can also see the new software version as it loads up. Once the new iOS appears to be working fine for a while, management will give you the OK to delete the old iOS to save memory. Do a show boot so you can copy the file name of the old iOS image. Then enter delete flash : and paste the old iOS image name. Make sure you remove the space or you'll get this error like I did. Once you press enter, it'll ask you to confirm. Press enter to confirm and then enter to confirm again. Now if you do a show flash : you'll only see the new iOS image. You successfully upgraded your first switch. Congrats! Now let's save your configuration, save your packet tracer file, and update your notes. Then create your narrative. After that, share the Google Drive folder you have for this lab with the anyone with a link can organize, add, and edit access. Then submit the lab for review. If you don't know how to submit the lab, refer to the instructions in the lab's intro video section of this program. After that, you can move on to the next lab.